So, welcome friend. That is the second class of the random variables. We are discussing about the random variables and the probability theory. Here, that part is the example of the random variables. So, let us consider a dice tossing, and here many more events can be created, and cumulatively all the possible events can be entered in a complete set called the sample space. So what I have told, that if you are tossing one dice means which having 6 faces, and here many more events can be created. It means if you are just having one simple experiment, you are tossing the dice 6 times, so different result may come. It may be 1, it may be 2, whatever it may be. But the question is this: suppose if you are tossing a die, so what is the probability of getting 1? That is 1 by 6. What is the probability of getting only the even numbers? That is 2. The probability of getting 2 is 1 by 6. The probability of getting 4 is 1 by 6. The probability of getting 6 is 1 by 6, because 4, 2 and 6, all these are the separate numbers. So if you are calculating, the total probability is PA plus PB plus PC. Here it is 1 by 6 and 1 by 6 and 1 by 6. So it is total 1 by 2. So that is why it is told that let us consider a dice tossing, and here many more events can be created, and cumulatively all the possible events can be entered in a complete set called the sample space S. So one sample space S may have all different possible events that may be classified in that particular sample space, or it may have only one sample point. So both things can happen. So now in the sample space, the events can come in two ways or many more ways. As S, if it is a sample space, here S can be written as the summation or that cumulative set of S, S1, S2, S3. It means S1, S2, S3, all these are the different sample points. These sample points are gathered in a single sample space, capital S here. So as it is a dice, so Sn equals to S6, and we can consider the equiprobable cases only. So what is the meaning of that equiprobable? Equiprobable means all should have the same probability. If it is not, so all the separate events if don't have the same probability, so it cannot be applied to them. So here in the case of dice, we are taking in this way that each and every faces have the same probability of getting it out. So therefore they can be an elementary set. Okay, that is elementary set of S1, S2, S3, S4, S5 and S6, or some subset event as number of even dots, number of odd dots, or number of 1 and 6 dots. In this way you can also create some sample space also. So each and every sample space should have the different number of dots or the sample points that already predefined by a set of rules, and that set of rules is governing that particular experiment from which you are collecting the sample points, and in which you are getting the sample space of that different type of combination of the sample points. Now for the sample points can be considered as, say suppose A is S1. So by a random process of the experiment whose operation is defined under a particular governed rule is earlier, we will create a function x of S1. Now second flowchart, actually I have represented the entire thing in a type of flowchart. The second part is probability of getting one dot in a single occurrence, and we will assign a value x1 to them. That x1 is a random number, and that x1, small x1, which I am telling, which is considering in the second point, that small x1 is a member of capital X of S1. So here x1 is a real valued number whose probability must lie between 0 to 1. Obviously, because it is a random number, and that particular number cannot be 0, cannot be 1. It maximum be 0, sorry, it it can be maximum as 1 and it can be minimum as 0, but it will always lying between that range. So next point, in other way we can represent that another sample point S is created as B. So here B will having S2, S4 and S6. So this is called the subset event. So the probability of getting one number of dot are consecutively say as P2, P4 and P6 if they are equiprobable only. But if they create set by P2 union P4 union P6 or P2 union P4 union P2 union P4, that is intersection, the reverse U, that is called the intersection sign, that I want to mean here. You can follow my slides. This particular point I want to mean here, this is called that intersection and this is called the union. Okay, so union means addition and intersection means subtraction in the sense, but not actually in the set theory. So here what is the meaning of P2, P4 and P6? Here if you are writing in this way that P2, P4 and P6, it means that you are adding all this. But if you are having this result only, that P4 and P2 will be summed first, then P6, so it will carry different meaning. If you are having this union, intersection, it will having some different meaning. Okay, so in this way you can create the different set. Okay, so they must be some subset of having non-equiprobable sites, that is to take a better function of x of S2, x of S4, x of x6 like this, whose domain is basically S. So the random variables must fall in a particular domain. This particular domain is named after S, and that S will have different sample points, or if S is a set of all points, so it must have some subset. So that subset, either it is one individual points, that S1, S2, S3, S4, this can be considered as a subset, or the subset may have that the sample points is not there. Suppose S1, S2 and S3, if you are combining these three sample points, we are creating one set inside that capital S. So this is called the subset. So what you have learned, that subset may have one single point, it may have more than one single point, but if it is a subset, it must lie inside the main set. So that main set is called the domain. The domain is called that S. Okay, so you have that idea what is a domain, what is a subset. So come to the next slide. And thus they can create some prefixed value which is must be outcome specific. So here suppose we are considering the event B. So in that case of B, we are having three random variables as x of S2, x of S4 and x of S6. So that particular random variables is associated with some particular random values which is lying between 0 to 1. Okay, so their probability of occurrence must fall in the range of 0 to 1. Okay. Now from the above discussion, it is very important fact that has come, that the random variables, if taken as equiprobable event with an elementary event, their nature is discrete. What is the meaning? That if a random variables, if taken as equiprobable event with an elementary event, their nature is discrete. Yes, because if you are tossing a coin, if you are tossing a dice, so whatever the output is coming, it is discrete in nature. So it may be 1/6, it is maybe 2/6, it may be 3/6, like anything else. So it may be anything, but the nature is discrete, so they are not continuous in nature. It means that two values, if they are don't having any mathematical relation in it, you cannot predict what will be the next stage, obviously. So no mathematical expression, no mathematical relation is there inside this number, so obviously these are the discrete in nature. So say for example, if you are tossing a coin here, if you are tossing a coin and you can see that the probability of getting head is ph, that is equals to half. Okay, now the probability of getting tail, that is pt, is also half. Okay, because two faces, head and tail, you are getting one, at least one at a time, so obviously the outcome is na by n. So it is n means 1, it is either head or tail, and the both is 2, so na by n is 1 by 2, so it is half. So they cannot be operated mathematically for a big cluster of data, so assign a value as ph equals to 1 and pt equals to 0. So here two random variables are being created as 1 and 0. So these variables is called the discrete random variables. Okay, what I am telling you to the last class. Okay, now if the result asked as find out the probability of getting a chance of all head each time of tossing n times, the answer is p of h1 into p of h2 into p of h3 and p of h4. In this way, half whole to the power n is a fixed value. So in the same way for trial, if you are taking as p of t1, p of t2, p of t3 in this way, so up to p of tn, if you are considering only head, so therefore, so the total number of trial for n times, the output is half whole to the power n for p. It is a fixed value. So here for an elementary event as sk, the random variables capital X of sk will fall in a domain of capital X of sk, it must lie between that range of minus infinity to plus infinity. So if you are taking this particular number, you just see this, wherever the value of n, it is plus 1 or plus 2 or plus 3 or plus 4, whatever. So actually the value must be either 1 or 0. Why? Because already I have considered that two cases, p of h equals to 1 and p of t equals to 0. So here if you are considering, so the number of head is must be lying in this particular region, that is half whole to the power n, and it is the case of 1 0. So what is the random variables here? The random variables which will getting this half whole to the power n, and that class is represented by that random value 1, and another random value 0 having the probability or the joint probability or the contiguous allocation for that value of half whole to the power n. So it is a single valued delta function of that amplitude of 1 by half whole to the power n. Here n equals to k. So finally we can say that we construct a function of distribution of such random variables which is discrete in nature and called the probability mass function. So what is a probability mass function? So probability mass function must be associated in a discrete nature function. That discrete nature function should have one specific value. Here for this particular case, whether for head I considered it is half whole to the power n, whether it is a case of 0 I considered half whole to the power n. But here one thing I have considered, that these events, it means the first experiment, the second experiment, the third experiment, all these are taken in this way that the outcome is either head or tail, but they are not interrelated. It means if the first outcome is head, the second outcome is either head or tail. We are not considering in this way, we are considering all the different experiment as an individual. So the first experiment the outcome is half, the second experiment the outcome is half, the third experiment the outcome is half, the fourth experiment the outcome is half. So nothing is dependent to its previous or the next steps. So that is why they are called in discrete in nature. So when that discrete nature function is plotted in that particular range of x of sk, that already I have given here, that x of sk, the range is minus infinity to plus infinity. Here that 1 and 0 are two sample points which is representing two delta functions. So basically this particular delta function representation is called that probability mass function, okay, that is PMF. So it is written in this way, okay, that P of capital X equals to small x, that is P of hk equals to half of k equals to 1, and P of t, this is to the power k equals to 0. So this is the random variable value, that is x, and it is 0 otherwise. So no mutual cases is being considered right here. So that is the conclusion of my today's lecture. In the next class we'll do something more on this random variables. Thank you very much.